measures of variation, day one. We're going to cover it all together. Another way to analyze the statistics is how spread apart the data is. The range is a difference between the highest and lowest. So when you put them in order, it's really important to subtract. I'm not going to go through that because you know how to subtract. The difference between the highest and lowest value. Two other ways to measure variation is variance and standard deviation, and they determine how far apart the data is from the mean. Okay, the bigger those numbers are, the more spread out the data is from the mean. The smaller the numbers are, the less spread out the data is from the mean. All right, now we are caught up. There you go. So the standard deviation is the square root of the variance. Your calculator will find the standard deviation. You will have to find the variance. Now, just the same way we can look at it in an inverse way, the variance is the standard deviation squared. This is the one that you'll mostly use, okay? Because the calculator is going to give you the standard deviation, and then you're going to square it to find the variance. However, in a problem, if you are given the variance, in order to find the standard deviation, you would just take the square root of it. We will be using the graphing calculator to find these values, okay? So we are going to, like I said, the calculator is only going to give us the standard deviation. We're going to need to calculate the variance, just basically squaring it. And the other thing, and I'm going to show you this for two reasons. One, if you're looking in your book, there's a formula for the sample standard deviation and variance, and then there's a formula for the population standard deviation and variance. And there's not only will you see it differently in the book and will it ask you for both, the formula is a little different, and also you will see different symbols in your calculator, so you have to know which one you're trying to find. Am I trying to find the sample or am I trying to find the population? So here are the formulas. Now, I'm just, you can write this down, and I'm going to talk about what it all means, but you do not necessarily need to memorize this formula. I want to give you a little perspective, because before the graphing calculator or a computer program came along, you had to do this by hand. And I want you to try to have an appreciation of how time consuming this used to be. First of all, population variance. This is a sigma, a lowercase sigma, so sigma squared, which means the sigma by itself is standard deviation. Okay? This is an uppercase sigma, which means sum of. And so what this means here is, remember I showed you that mu was the population mean. Okay, so essentially what someone had to do in the past is they would have to take each data value in the list, subtract the mean from it, square it, and then add all those up first, and then divide by the number of numbers. That's what you used to have to do, and your calculator is going to do all this for you, but I just want you to have a little appreciation for how much work was involved. Subtracting the data value, subtracting the mean from the data value, squaring it, and then adding all of those up. So depending on however many values there were, you had to do that subtraction and squaring that many times. Okay, so if you had a small data set, it wasn't going to be too bad. But if you had a data set of 100 data items, this would take you a while. Okay? The sample variance. Now, you're going to use this mostly in your calculator. So in your calculator, you're going to see lowercase sigma, and you're going to see an S. They will both be there. Okay? The difference is just notation. You're still subtracting. This is the sample mean from each data value, squaring it. And the only adjustment that gets made is you divide by n minus 1 instead of n. Because you have to account for the fact that you're missing part of the population. And so you reduce what you divide by to counter that.
What's the line on the X mean?
The X with the bar on it, that is the sample mean. And when we went over sample mean and population mean in 3.1, we had a mu and we had an X with the bar on it. The population deviation for the sample, and okay, all this is, now, hold on, stop please. We're going to go through an example. But all this is, okay, this looks like a lot, but all it's saying is take the square root of this. Okay, square root of this gives me sigma. Take the square root of this. Take the square root of this. It gives me S. Okay? Again, you don't have to memorize these formulas. I wanted to show you them for perspective. I wanted you to see the difference between the population notation and the sample notation. But we're going to do this all in the calculator. We're going to go through. So here's the... Are you still right? We're moving on. Here is the example we're going to go through. Okay, so I want you to take a picture of this screen, please. Here we go. So here's what we're going to do. We're going to calculate the range, population, sample variance, and population sampled standard deviation. Actually, I told you to take a picture too soon. Let's... Yes, here. So now it's like a fill in the blank, okay? We're gonna work on, because you don't even know how to do this yet. So I'm gonna show you how to do this. The range you can do. I want you to do the range right now, please, and then I will show you how to do this on your calculator. All right, let's find the range first, and then I'll show you how to find the standard deviation and variance using your calculator. All right, now, what is the range for A? What's the biggest value? 60. What's the smallest? 10. So the range is going to be, okay. For the second one, the biggest value is 45. The smallest one is 25, so the range is 20. Now, what's interesting about this is that here's why central tendency isn't always the best way. Each data set, you just trust me here, if you wanted to calculate it, you could. The mean for this is 35, the mean for this is 35, but clearly we can already see that, I mean, and just from a glance, we can tell that brand A is more spread out than brand B. But we can prove it more so using standard deviation and variance. Okay, so we've got our populations over here. So population variance, population standard deviation. Okay, sample variance, sample standard deviation. What you're going to do, in your calculator, go to the stat button and then hit edit. Okay, I want you to clear all your lists out that you might have in there right now. Do not hit delete, hit clear. Okay, so go to edit, and what you should have in your calculator, I want you just to enter enter brand A in list 1. Enter brand A in list 1. Actually, you can enter list B in list 2 if you want, and I'll show you how to toggle between the standard deviation and the for each list. So enter them both. Brand A in list 1, brand B in list 2. Okay, now after you enter your list in, okay, what you're going to do is hit stat again and then slide over to calc. And the number 1, the first option, after you've entered your list in, hit stat, arrow over to calc, and the very first list number is, or the very first option is 1 variable statistics. You're going to hit enter on that.
But on your calculator, it'll say 1 var stats. It means 1 variable statistics.
That is correct. Thank you, Christopher Baker. You've made the video. Shush. Oh my goodness. Okay, now, if you notice, at the top, when you hit enter on that, you'll get a screen that says list, and it says L1. Okay, so that means what it's going to do is it's going to calculate from list 1, which in order to find brand A, in order to figure that one out, that's the list we want. All right, frequency list we don't have to worry about. Then go down to calculate, hit enter, and you're going to get a screen. And on that screen, you get the sample mean, x with the bar over it, 35. We already knew what that was. Then you have the sum of the x, the sum of x squared. We don't need any of that. Below that, you have S of x, which means sample standard deviation, and then you see sigma of x. That means population standard deviation, okay? And so what we're talking about from that list is you're going to get sigma, you're going to get S, okay? So that's what we're going to do first one. And since the data is all integers, sigma is 17.1 rounded up to 1 place. S is 18.7 rounded to 1 place, okay? How many of you got that? Raise your hand if you got that. Very good. Now, all you need to do is take this number and square it to get the variance. Take this number and square it to get the variance. So please do that now. All right. So when you square both of those, you should get 29.4, 349.7. So that's the variance. So you got population, variance, population standard deviation, sample variance, sample standard deviation. Now, since you already entered brand B into list 2, go back to the stat button and calculate, and then one variable statistics again. Now you have to change the list. So instead of pulling from list 1, you got to make it pull from list 2. And if you see that it's right above the number 2, the blue, hit the blue button, the second button, and then hit number 2, which is where the L2 is. Oh, actually, you might not have to hit the second button because it's already there. Yeah, well, it's always one more place than the data. So then once you make that L2, you just hit calculate, and it'll give you the new data. So for the population standard deviation, I get 6.5, and for sample standard deviation, I get 7.1. Once you have that, you just have to square each of those to find the variance. Okay, so do that, please. Most of the time, you're only going to have one list. I put these two to just show a comparison so we can see that even though the data has the same mean, the spread of the data is very much different. And so if we look at this, what we should be able to conclude is that because these numbers are so much bigger than these numbers, that B is spread out less, or A is spread out more than B. Meaning, this data is more closely bunched to the mean than this, which we could tell from this data anyway, because it's a small set of data. But, I mean, if this was, 10 and 11 versus 6.5 and 7, that data is going to look closer together. So I just wanted to show you that as a side-by-side comparison. So since we can tell by the naked eye that this data is closer together than this, we would expect these values to be smaller than these values. Okay. So again, that's another way, especially because the mean is the same for both, that we can look at data and look at the spread. Now, here's the part that I changed that is going to be so much nicer for you instead of what my other students have done in the past. Okay? And that's when we have to find variance and standard deviation from group data. I'm going to show you the very last slide, and you're not going to have to write the very last slide down, but I'm going to show you how ugly the formula is and what used to have to happen until I figured out that we don't need to do that at all. Okay, so I'm going to give you, this is the same data we used some other time, I believe. Yeah, when I first showed you, when we were finding mean from group data. I think this is the same data from that, so if you want to grab it from there, you can. But remember, what did we have to do for this? What did we have to assume when we were trying to find mean from group data? Because we don't know the actual data. What do we have to find? Midpoint. So I need the midpoint again. Okay? And I already had calculated that. So we needed the midpoints, and we've already looked at this one. So what we do for this, to find the variance and standard deviation, is we actually have to type all the midpoints in to our list. Okay? And when we type those midpoints in, because we're pretending that there's 1 8 and there's 2 13s and there's 3 18s. We're going to type all that into our calculator in our list. Now in this case, we've got 20 data values, I think. 6, 11, 15. Yeah, 20 data values that you're going to have to enter into your list. And if you weren't sure, here's what it looks like. This is what you're entering into your calculator. So there's 1 8, 2 13s, 3 18s, 5 23. So you're going to have to enter all this in your calculator. In the list.
In list 1?
Sure.
Whichever list you'd like.
Yeah, you can put it in whichever list you'd like, but I suggest putting it into list 1.
So we're clearing the
Yeah, so you're clearing the old lists out, and then you're entering this in. So this is the group data, because again, we don't know what the data actually is. We're pretending that the midpoints are the data. And if you enter that into your calculator and do the one variable stats like we did for the other lists, then you find your standard deviation, and then you square it to find your variance. Okay, and that's what we're going to be doing here. So after you have entered this all in, and now the other thing is you're using sample. In this case, we do not use population for a couple reasons. One, we don't even know what the data is. So we certainly couldn't conclude that this represents all of the data in a population. We will use sample, and most of the time we will use sample because truthfully it's hard to ever come up with data for an entire population of anything. Okay? So you're going to use the S one, not the sigma one. Then go to stat, calculate one variable statistics, hit enter, and you're good to go. And it'll give you your same values. Okay? So your standard deviation should be 8.3. How many got that?
Oh.
Good. So then what's my variance? Just got to square that. 68.9, bless you. So again, all you're doing is squaring that. Now, Chris is actually experimenting with something where it says frequency list. Now, this won't work on everybody, but we may be able to enter this table in just like this, and you assign the, like, maybe, for example, you make L2 the frequency, L1 the midpoints, and if you tell when you hit enter on one variable statistics, if you assign the correct column or the correct list to frequency list, it may calculate it for you.
Yeah, let me see if I can.
You can enter this table directly into your calculator, and the thing is when you get to the stat calc, right, it gives you an option to select which list the data is in, and it gives you an option to select which list the frequency is in. So for example, if I listed this in list 1, where it says frequency list, you have to assign that L1. If I enter the midpoints in L2, and then you don't have to enter them all in like this, it will actually do the calculation for you, and it will understand that there's 1 8 and 2 13s and 3 18s. If you want to do it that way, you don't have to. You can enter it in all like this. It's up to you. I don't care which way you do it. But it does require a different step when you do your stat calculation, because you have to assign the frequency list, which that's what this is. The frequency is this list, into one of those lists. You have to type that into one of the lists, and then you have one that's from L1, one that's from L2, and you still get the same thing. So here's the formula that I used to make kids memorize.
Bonus points for that.
Okay? So, yes, this is what we used to do. There was this giant table where you had to take the sum of the frequency times the values, the midpoint squared. Then you had, that's a nightmare. Your calculator will do it all for you, and so that was something that I figured out. Okay?